Hi everybody. Last time we were looking at this table, we determined that the table was in 1NF, and 1NF requires, or first normal form, requires that all the values in each row are atomic, which they are, and that each row has some sort of unique identifier called a primary key. And the CRN here in this case is the primary key because each value in that column makes that row unique, right? So we have this 10405 that makes this whole row unique. 2NF requires that the table be in 1NF, plus it requires that the table contain no partial functional dependency. Now, functional dependency just means that one column of a table is dependent on another column. So if the value of one column changes and that requires that another value or another column changes, that means that there's a functional dependency. This no partial functional dependency means that if we have a composite key, a composite primary key means that the primary key is made up of more than one column. So we have like a two-column composite primary key. If the value of some non-key column is dependent on one of those columns of the primary key, but not all the columns of that primary key, then we have what's called a partial functional dependency. And if we have a table that's in 1NF and the primary key is only one column, then necessarily that table is in 2NF. And that's what we have here. So we have a one-column primary key. The table is in 1NF. Then this makes the table 2NF. So what about 3NF? Requires that the table be in 2NF, and it requires that there are no transitive functional dependencies. Transitive functional dependencies mean that the value of one column in a table is dependent on the value of another column. Specifically, the value of one non-key column is dependent on the value of another non-key column. And in this case, we do. We have this dependency between title and course. So if course changes, so if this were a mistake and it was really 220 here, then necessarily we'd change this title column. So we have that dependency. We also have this dependency here, that the credits column is dependent on the course. So 110, for example, is 3 credits, but if we made a mistake and it was really supposed to be 220, we'd have to change this to 4 credits. So this is not in 3NF. So last time we changed this table. Let me bring that up. Okay, here that is. So we divided that information into 2 tables, and each table is in 3NF. 3NF means that all the values of a row are atomic, that we have a primary key that makes the rows unique, in this case CRN in this section, that because the primary key consists of only one column, it's also in 2NF, and 3NF means there's no column that's dependent on the value of another column. So section here is not dependent on course, or course is not dependent on section. And it's the same here with this courses table, that all the values are atomic. We have a primary key, a one-column primary key. Because it's a one-column primary key, this is also in 2NF. And there are no transitive functional dependencies, so that makes this 3NF. All right, so let's take a look at another table. Okay, so here's the familiar band table. One requirement of 1NF is that it has a unique identifier or primary key, and band here seems to fulfill that requirement. Those values seem to be unique. The other requirement is that it only contain atomic values. That constraint is violated here. We have a number of values that are of the same type, this Chris Martin, Johnny Buckland. So it's not atomic, and this table is not in 1NF. So here I have a table that repeats the band, but now we only have one member. Instead of those columns of multiple members, we have a table here with a band, Imagine Dragons member Dan Reynolds, Imagine Dragons Wing Sermon, and so on, the members of Imagine Dragon here. So now we have each row having atomic values. For primary key requirement, we could put, well, let's go with the composite key here, band and member. So we have a band and member composite key. So we have a primary key, atomic values, we're in 1NF. Great. What about 2NF? 2NF requires that the table be in 1NF and also that there are no partial functional dependencies, meaning that a column in the table is not dependent on one column but not both columns of the composite key. Well, here we violate that. So here we have this member real name is dependent on this column, member, this band formed. If we switched bands, this column would have to change, so that's dependent on band. Birthplace refers to Dan Reynolds, so if the member Dan Reynolds changes, we'd probably have to change this birthplace. So we have all these partial functional dependencies. So it's not in 2NF. We could fix that by just having a synthetic key here. Whoops, I kind of lost my drawing here. Let's just call this ID to keep life short and just number them. So no longer are these columns the primary key. The table was in 1NF, still is in 1NF. And if a table's in 1NF and has just one column being the primary key, it's necessarily in 2NF. So now we're in 2NF, but this just kind of postpones the inherent bad design of this table, as we'll see. So if we look, is this 3NF? 3NF requires that we have no transitive functional dependencies, but we do. So these are now band and member are now non-key tables. We have all these dependencies we had before, so that now they're transitive ones, so the table's not in 3NF. So this is not a good design. So let's just stick with this table for a minute. We also have this problem that if we wanted to add one instrument people play, well, some people play two instruments here, so electric guitar and piano. Drums and vocal here. Bass, this person does a lot. This Ben McGee, the bass player for Imagine Dragons. So we have multiple instruments here. There are multiple things of the same type in one column. So that violates 1NF. So we'd have to change that a bit and maybe do something like this. Okay, so here we have this, we just added instrument to this composite key, and now we repeat. People who play multiple instruments are going to have multiple rows here. Imagine Dragons, Wing, Sermon, electric guitar, and then Wing also does piano, so we'll do another row for that. So this, you can see, is probably not, you can intuitively tell, I would hope, that, man, this just does not look like the way to go. There's a lot of repeated information, looks kind of ugly. So even though we can force it to be 1NF, and we can even force it maybe to be 2NF by just adding a synthetic key here, this one column primary key. But so that would make it 2NF, but it's pretty ugly looking, and it's definitely not in 3NF because there are all these transitive functional dependencies. Again, the member real name's dependent on member here. The band formed is dependent on another part of the key, this band thing. The birthplace is dependent on Dan Reynolds. So we still get all these ugly dependencies. So this table is not in 3NF. It's just an ugly design, even though we could force it to be 2NF. So before I talk about really how to fix it, I just want to take another angle at this whole thing and explain things from just another view. And in this view, I'm going to look at things, relationships among entities. And one relationship we could have is a one-to-one relationship. So we have some sort of object here, and for every object, it's associated with only one object of some other type. So it's hard to come up with examples really for one-to-one. Every time I think about it, I lose track of the one-to-one. But a good example might be if this object were just the course name, CPSC 110, and this were the actual title, intro to whatever. So right, there's a one-to-one relationship here. For every course number, we have one unique title, and for every title, hopefully, we have one course. More common is a relationship called one-to-many. It means there's some object here, and it can have many connections with other types of objects. I'll explain what I mean. Or the reverse, there can be multiple objects that all go down to relate to one object. So an example might be courses. We've seen that. So if this were CPSC 110, then we have different sections of it and CRN. So this could be section 1 here, 2, 3. So one course is in a relationship of many to the sections, and sections are in a many-to-one relationship with the course. Right? There's this kind of mirror thing. Or we might have a publisher and a book. Book, publisher. So a book only has one publisher, but a publisher has many books. So again, it's this one-to-many relationship. Or maybe we can think of automobiles. So we have some car here, my truck, F-150 pickup. It's made at some assembly plant, and that assembly plant is unique for this truck. Hopefully, it didn't bomb around with multiple assembly plants, but that assembly plant makes multiple trucks, or multiple vehicles. So that's a one-to-many relationship between an assembly plant and cars. So when we have a one-to-many relationship like these I just explained, it means that we can't have one table. One-to-one relationship, we can do everything in one table. If we have a one-to-many relationship, like we've seen in this example here with courses and sections, we need to have two tables, and we're going to link them by something here. We'll have some relationship here. So we'll have a key here that's a foreign key in this other table. So one-to-many means we need multiple tables, two tables. There's also relationships like many-to-many relationships. And this one we've already seen, a many-to-many relationship. So we have bands. Let me get my cursor here. And we have musicians. So here we have Imagine Dragons, and here we have the musicians in Dan, Simon, and so on, all these musicians in Imagine Dragons. And these musicians can be in multiple bands as well. So here, let me get his name. I spaced out on his name. Sorry, Dan. I can't remember the name of Dan Reynolds, the guy in Imagine Dragons, also is in a band called Egypt. So if this were Dan here, he not only would he be associated with Imagine Dragons, but he'd be associated with some other band here. So it's not a one-to-many relationship, but a band can have many members, and one person can belong to many bands. So this is a many-to-many relationship. And if we have a many-to relationships are pretty common. And if we have a many-to-many relationship, what this typically means is that we need three tables. So we're going to use three tables to represent this relationship of bands to musicians. So many-to-many means two tables aren't going to work. This scheme won't work. We'll need multiple tables. And let me just kind of illustrate that for you now. Okay, so here is the start of my bands and musicians approach. It's not the full solution. So I have a bands table. It has this little synthetic key band ID. I guess I don't really need that, but maybe there's multiple groups with the same name, so I'll just go with that. Nothing depends on that synthetic key. So I have the name of a band, the genre they're in, so various information about bands, when it was formed, maybe the home where it was formed, information like that. So for right now, I'm just sticking with genre as a single column just to keep life easy. You'll see in a second how we can change this to how I handle multiple genres. And then musicians, I have primary key musician ID. I have the member's name. Sometimes people go by names that are different than their real name, so I have this column real name. So happens to be in Imagine Dragons 3 Daniels. which you'd think would be confusing. So they go by different names. We have Dan, Daniel, and Wing. Wing takes Wayne's the middle name here. So I keep track of the real name, the birthplace. You can imagine other information, birthday, when they were born, who knows, all sorts of information there. So we're going to go with this. So let's see how what we need to do to connect these two, because bands have multiple members in the band, multiple musicians, and Dan Reynolds can, for example, is in both the band Imagine Dragons and is in this band Egyptian. So let's see how we can fix that. All right, so I added a table, and this table is called a junction table. Let me get that real quick. So that's a junction table. And that simply means that this junction table is the kind of the glue that connects two tables together. So here, this band ID, musician ID, so band 1, so Imagine Dragons in this case, it links Imagine Dragons to whoever musician 1 is. Musician 1 is Dan Reynolds. So band ID 1, Imagine Dragons again, is also linked to musician ID 2, that's Wing Sermon, and so on. So it kind of joins or functions as a junction between two tables. And the composite key is both this band ID, musician ID, so it's unique here, and it's a way of very succinctly, we don't need to repeat Dan Reynolds, Dan Reynolds, Dan Reynolds a whole slew of times somewhere. We can only have one occurrence of it, which is nice when we're doing updates. We're not going to like change Dan Reynolds and fix it in one place and forget to do it in another, or update it. We only need, or Imagine Dragons changed and now we want to make their genre something else. We only need to do it in one place, rather in our previous design where we had a lot of repetition. So it's one of the benefits of making 3NF tables and having this scheme of having this junction table. So we know we're going to need a junction table, or there's some indication that it is, because we have this many-to-many relationship. So let's go down a little further. So band 2 has musician 1 in it. So it's Egyptian. Musician 1 is Dan Reynolds. So Dan Reynolds is also in this group, Egyptian. So that's what this junction table does for us. And this is a really nice design. This is correct 3NF form. Let me just augment that a tad. Okay, and now here I'm doing how to encode when one person plays multiple instruments. So here I have Dan Reynolds. He plays he's a vocalist and a keyboardist, so I represent it in this little plays table I have. So musician 1, in this case Dan Reynolds, plays vocals. Notice I didn't make a little instrument table here with an index of 1 and it being vocal and then having a junction table. I don't need that here. The only information I have is the name of the instrument. If I had more information about instrument here, instrument family or whatever, I'd make a junction table. I'd have a separate instrument table, but you don't need to mess up the design by having unnecessary multiple tables. Here I had this junction table with numbers because I had a bunch of information about bands and a bunch of information about musicians, right? So that's why I needed this junction table. So musician 1 again plays vocals. Musician 1, Dan Reynolds, plays keyboards. So this musician ID here is a foreign key and relates to this musician ID in the musicians table. So this is really a fairly complete design of this kind of sample and somewhat trivial database. Let me show you one more thing. And what I wanted to show is, well, how would we do this query, just kind of get a cognitive sense of it before I show you how we do it in SQL. But we're trying to find out who are the musicians in Imagine Dragons. So the first task we might consider is, well, let's find out Imagine Dragons. That's here in this bands table. And we see that it's the band ID 1. That brings us all the way here to the band musicians table. And we're going to look at all these ones. Well, band ID 1, we have musician 1. Musician 1, we go to, is a foreign key to this thing. So we can get the name Dan Reynolds. The next find we find for Imagine Dragons, band ID 1 is this row. We find the musician ID 2. Off we go into the musicians table, find Wing Sermon, and we continue with all these ones here, finding the musician ID, looking up that musician ID in the musicians table. So you see we're making use, for one query, we're going to be using 3 different tables in our database. Okay, so let's see how we can do this in Postgres. So let me get the file I made here. So here's that representation of what I showed before in SQL. So I create a table band. It has this band ID, that's the primary key, the name of the band, the genre, and form. That kind of matches what I showed before. Let me just kind of get that up to, give me a second to get that image up. Okay. So there that is. All right, so I had this bands with band ID, name, genre, and band formed. That's here. And then I just insert some examples. I create this table musician with an ID, which is the primary key, the stage name, the real name, where they're from, like Milwaukee, Wisconsin, or whatever, and birth date. And it's just an expansion here of what I had here. Then we had this band's musicians junction table. There's all the inserts for the musicians. And I'm calling that junction table bands member. So I have band ID here. It references band ID. So the primary key of this band. Same thing here with this member ID references musician ID. And then I just insert a bunch of like who's in what band here. So band 1 is associated with band or musician 1. So band 1 was Imagine Dragons. Oh no, Heavy Metal or Baby Metal. I hope this is working. Yes, that's right. And musician 1 is Sue Metal. I have this instrument table with an integer, which is the primary key. This is different than my original design, because not only do I give an instrument here, but I give the family. So I say vocals is of subclass of is a type of voice. Screams, there's in baby metal, there's people who, when you look up what instrument they play, they're screamers. So their voice. Koto's a string instrument, electric guitar is a string instrument, drums are percussion, and so on. And then I have this junction table plays. So some musician plays some instrument. And you see here, one musician 1, plays 2 instruments, musician 2 does a couple instruments, and so on. So let me get that out of the way. All right, I could have kept that there. Let me close this here. Let me bring up a terminal window. Okay, so let me bring the terminal down here. All right, so let me start my virtual machine. So this is a machine that's running just locally on my Mac. Takes just a second to bring up. And just another second. Okay, now let me SSH into that machine. All right, now I'm running, I was on my Mac terminal, now I'm in Ubuntu. So why not? Let's go into Postgres, the usual way we know. Okay, let's take a look at our databases here. That it's the bands one I'm interested in, so let me change into that. And the tables are the ones I've kind of talked about. So I have a band table, a band member table, instrument table, musician. So band members, the junction table that links band and musician. Plays is the junction table that links musician and instrument. Let's just take a look at a couple of those, I guess. Why not? So there's the band 1. So we have band ID. That's our primary key. It says so right down here. The name of the band, the genre, when it was formed, the year it was formed. And we know that this band ID here is a foreign key. Its reference is band ID in band member. So it's a foreign key there. If I look at band member, let me do that right quick. So here we have, this is our junction table, and we have the primary key. This is how it's illustrated, is both columns. Let me just bring that code up again just so you can see how that works. So in tables that have one primary key, one column primary key, you can state the primary key right here when you design the table. An alternative way is just to list it, not to reference it up or describe it up here, but just list it on the bottom. And this is the only way you can do it if there's a composite key with multiple columns. So with one column, you have a choice of declaring the primary key up here, or I could have stuck it at the end. I could have just said primary. The alternative here would have been primary key ID and close that off. But since I already have it up there, I'll get rid of it. But we need to do that down here because it's a 2-column composite key. And also I'm declaring both of these as reference foreign keys, so it references the musician table, musician ID, and the instrument table, that ID as well. All right, so I see I screwed up in my definition, I believe. This should be musician ID. Oh no, sorry, wrong thing. All right. All right, so let's say I'm interested in finding all the band members of the group Imagine Dragons. So I have the band up there listed right up here. I have the band member information there. And let me just display the other one I need, the musician table. So I'm going to go from band name to the musician stage name. All right, well, let's give it a shot here. So the first step is the easy one, select. Whew. All right, so now the table I want to display the musician stage name. And let's say that's all I want. Okay, now I have to describe all the tables I need, plus am I linking the tables. So it's from musician, and I want to join that to the thing that connects everything, band member. So that's the syntax there. I'm going to join 2 tables, and now I need to say, well, how am I going to join those tables? Well, I'm going to go, it's musician, so in the musician table, the musician ID should equal the band member table member ID. So now we've linked this musician ID here has to match the musician ID or the member ID here in this junction table. So I've connected 2 tables now. Now I need to connect the third one. And that one's called, I think, just band, but let me just double check. Band. So how am I going to connect all that big thing I just constructed to band? So that's the on. Well, I'm going to connect it to, it's going to be band member dot band members here. So that band ID here needs to match band. I think it was just called band ID. I sure hope that's right. Well, I better go check. Yes. So now I've linked all 3 tables together. It's quite a bit of code, but let's go with it. And now I can have that where clause. Where band name equals Imagine Dragons. So that's my select statement. I think that may work. It shows you how confident I am. Let's give it a shot. And it does. So here I have the 3 stage names of people who are in Imagine Dragons. Let's go further and, well, let's try this. I'll let you people work on this for a minute, and then I'll pause the video and explain. So let's say I want to find what instruments do Ben McGee play? So I think I had a syntax error there in my sentence. Let's try it again. So what instruments does Ben McGee play? I did the same error twice. So there, let me show you the relevant tables we'll need. We'll need a musician table for sure. Oops, I didn't do the describe. There's that one. I'm pausing for a second. There's a plays, I think it's called plays tables. Maybe it's just the singular. No, there it is. Plays table you'll need. And finally, you'll need the, oh shoot, what did I call it? Instrument table? Yes. So I gave you the 3 tables you'll need. Let me see if I can just make this a little bigger so you can see it. Oh, it's not going to be easy, is it? So can you construct a query that will give me, I'm curious about Ben McGee. I want to know what instruments he plays. And pause the video now. All right, hopefully you got that figured out. Let's give it a shot here. So, all right, so that's the easy part. Select, I want to know the instrument name. So that's in my instrument table. It's called name. From instrument, join plays on plays dot instrument ID. So here we see a case. These names don't have to be the same. So here I have an ID and here I have instrument ID. There's no need for them to match or anything. Any names you want. So okay, I got that. So I think I joined those 2 tables up. Now I need to join the other table in instrument, join plays on instrument equals plays instrument, join musician on musician dot musician ID equals plays dot member ID, where musician name equal stage name. And now I don't know was it stage name was Ben McGee. All right, let's see if that works. Oh no. Okay, so I simply misspelled instrument, as you guys probably noticed while I was typing. So let me see if I can go zipping along fixing that. That's why I never expect things to work the first time. But nevertheless, I still get panicked when it doesn't work. Like, oh my gosh, it didn't work. But okay, here. All right, so that was simple. It just says bass. That was the only thing Ben McGee plays. All right, let's check. What about Sue Metal here? I don't know what Sue Metal plays. Oh, she plays vocal and dances. All right, sweet. All right, and what about Dan Reynolds? Let's see what he plays. Okay, so he's vocals and keyboards. So I hope this video showed you kind of how to take your idea of what you need to store in a database or in a table, how to divide it up to make all the tables 3NF in a database, and design, make a good structure for the database. And finally, then once you get this structure, how you can actually generate queries on these structures. And the key points were first, second, and third normal form, these relationships of one-to-one, which indicates you can probably do everything in one table, one-to-many. Most of the time you do it in multiple tables, and many-to-many, that's when you need this thing, a junction table. There are certain circumstances where you don't, which I illustrated by the earlier in the video when I was showing you how plays works without having a lot of attributes for plays. But those are the key points here. I hope this helped. Take care.